Okay, hi everyone. We have two theorems we're going to deal with our polynomials and division and such. The remainder and factor theorems. And here's the remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is f of k. Alright. Let's see how we can use that a little bit. Example 1. Write the function in the form f of x equals x minus k times q of x plus r. Then demonstrate f of k equals r. So, I've got f of x equals x cubed minus x squared plus 2x minus 5. I've got k equal to negative 3. So we are really dividing by x plus 3. So that means that actual value here is what goes in the box. I'm going to set up synthetic division for this and use negative 3. And I've got 1, negative 1, coefficients here, 2, and then the constant's negative 5. And I'm going to bring down that 1. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 times negative 4 is 12. 2 times 12 is 24. Negative 3 times 24 is negative 72. Negative 5 and 72 is negative 77, which is my remainder. Okay. And let's just keep checking this through here. I'm just checking 1, negative 1, 2, and negative 5. 1, negative 3 times 1 is negative 3. Add, that's negative 4. Negative 3 times negative 4 is positive 12. That's 24. Negative 72, negative 77. All right, we're going to find out if that's right here in a second. But f of x, so what we're doing, f of x is the x cubed minus x squared, when I'm going to write it, do this part right here, plus 2x minus 5 should be equaling x plus 3 times x, remember this part, squared minus 4x plus 24 minus the remainder, 77. Now plus negative 77, if you prefer. Okay, I'm curious to make sure f of negative 3 is actually negative 77. So I'm going to take negative 3 to the third minus negative 3 to the second plus 2 times negative 3 and then minus 5. Something just doesn't feel, oh my goodness. Okay, here's my problem. 12 plus 2 is not 24. 12 plus 2 is 14. Can we go back? I'm very sorry. Negative 3 plus times 14 is negative 42. So that's negative 47 there. And I need to change that to negative 47. Okay. Alright, all's right with the world now. But I kind of goofed. You know, I think you just saw history made there. That was my first mistake of the year. Alright, so let's take a look here. Negative 3 to the third power is negative 27. Negative 3 to the second power is 9. Negative 27 minus 9. Negative 36. 2 times, well, let me just get this written down. That's negative 6 minus 5. So I did say that's negative 36. Negative 36 minus 6 is negative 42. Negative 42 minus 5 is negative 47, which does match the remainder here. Okay, example 2. Use a remainder theorem to find each value given. I have f of x equals 4x cubed plus 10x squared minus 3x minus 8. And, oops. Okay, what did I want to find here? I didn't want to do f of x there. I wanted to do f of 4 Okay, so I'm going to, when I use synthetic division, I'm using the remainder theorem. So we're going to use the division algorithm to do this. Rather than just plugging in -1 into these places and getting the answer, I'm going to use the remainder that we get from synthetic. 4, 10, -3, -8. Bring down the 4. -1 times 4 is -4. 10 and -4 makes 6. -1 times 6 is -6. -3 plus -6 is -9. -1 times 9, -9 is +9. -8 plus 9 is 1. So I'm saying f of -1 is equal to 1. The remainder is that same value. All right, this one, let's put the 4 in. Still use the 4, 10, -3, and -8 for our coefficients. And I bring the 4 down here. 4 times 4 is 16. 10 plus 16 is 26. 4 times 26 is 104. -3 plus 104 is 101. 4 times 101 is 404. 404 minus 8 is 396. So I'm saying f of 4 is equal to 396 because it's the remainder when we use the synthetic division there. All right, next is the factor theorem. And here is the factor theorem. A polynomial f of x has a factor x minus k if and only if f of k equals 0. If the remainder is 0, it's a factor. Just like if you were dividing 38 by, or let's do 36 divided by 9, well, you'd get 4 with no remainder. That's probably not the best example, but if we did a longer problem and you had no remainder, you would know that that is a factor. So let's look at this example. Let's show that x plus 3 is a factor and x minus 4 is a factor of 2x to the 4th plus 7x cubed minus 38x squared minus 103x plus 60. I'm going to use synthetic. I'm going to start with the x plus 3. And -3 would go in the box for synthetic division. I got the 2, the 7, the -38, the -103, and the 60. I bring down the 2. -3 times 2 is -6. 7 and -6 make 1. -3 times 1, that is -3. -38 and -3 make -41. -41 times -3 is 123. -103 plus -123 is 20. -3 times 20 is -60, and that is 0. That shows f of -3 is equal to 0, so that means x plus 3 means that x plus 3 is a factor of f of x. Okay. Now when you divide that out, you get 2x squared, 2x to the 3rd plus 1x squared minus 41x plus 20. That is the quotient when you divide f of x by x plus 3. Okay, now I want you to think about something here. F of x, and I'm just going to, for this one time, for the demonstration, f of x is equal to x plus 3 times 2x cubed plus x squared minus 41x plus 20. Okay, that's from our work. If this divided by x plus 3 is this, then x plus 3 times 2x cubed plus x squared minus 41x plus 20 is equal to this f of x here. All right, so I could put, because we're also supposed to show x minus 4, I could divide this by x minus 4, but I've already kind of factored out the x plus 3 and gotten this. So I'm going to use this, just this part, and divide that by x plus 4, or x minus 4. So this is for x minus 4. I'm going to just do this part, which is the 2x cubed plus 1x squared minus 41x plus 20, without the x's, without the variables. Put the 2 down here. 4 times 2 is 8, and 1 make 9. 4 times 9 is 36. Negative 41 and 36 is negative 5. 4 times negative 5 is negative 20. That gives me 0. All right. And I've got, so x minus 4 is also a factor. Now, 2x squared plus 9x minus 5, that's when we divided by, is what we've got when we divided by x plus 3, and when we divided the what was left by x minus 4, we came up with this. I forgot to write in my instructions. It would have said, then find the remaining factors of f of x. I meant to have that up here and I forgot to write that. So that's what we'll do now. In other words, I want to factor 2x squared plus 9x minus 5. And I need to make sure two numbers will multiply to negative 10 and add to 9. Let's see, 10 and 1. Let's make that negative. So I got 2x squared, I'm just factoring right now, plus 10x minus 1x minus 5. And the GCF of those two is 2x. And I'll go x plus 5 when I factor 2x squared plus 10x. And let's take the negative 1 and go x plus 5 there as well. And x plus 5, that's the common factor there, and 2x minus 1. So the remaining factors are x plus 5 and 2x minus 1. So basically what we've done, they gave us x plus 3. We had to show that was a factor though. They gave us x minus 4. We had to show that was a factor. We found after we did that x plus 5 and 2x minus 1 is the factored form of what was left when we divided by this and this. It's a factor if the remainder is 0, remember? And that's equal to 2x to the 4th plus 7x cubed minus 38x squared minus 103x plus 60. All right. You guys take care.